Hello and welcome, and thanks for joining us for this media briefing on the role of carbon management technologies in reducing industrial emissions. My name is Ben Finzel from RENEWPR in Washington, D.C., and I'll be the moderator for today's event, which is hosted by the Carbon Capture Coalition and the Industrial Innovation Initiative. We have a terrific lineup of speakers today, and we're going to hear presentations from each of them before opening the conversation up for questions from you, the reporters who have joined us today. But first, let me provide an overview of our agenda for today. We're going to start with brief remarks from our two co-hosts, Carbon Capture Coalition Executive Director Jesse Stolark and Industrial Innovation Initiative Industrial Decarbonization Manager David Soul. From there, we're going to have brief presentations on carbon management in the industrial sector. We'll start with Ben King, Associate Director at the Rhodium Group, who will share insight into recent research which found that the industrial sector is on track to be the highest emitting sector in the US in the next decade. Next, we'll hear from Leilac Limited CEO Daniel Rennie about the challenges and opportunities of decarbonizing industry. And then Rohini Sengupta, Decarbonization Director at United Airlines, will highlight the importance of carbon removals as part of the value chain that facilitates sustainable aviation fuel for one of the world's largest airlines. Finally, Kevin Pranis, the marketing manager for LiUNA in Minnesota and North Dakota, will talk about the role of labor in supporting the decarbonizing of industry and protecting high-wage jobs. After that, the remainder of our time together will be devoted to a live Q&A. I'll be reading your questions from the chat and also providing you the opportunity to ask questions live. If you'd like to put questions in the chat now or at any time during our conversation, you're welcome to do so. You can also wait to ask your question live when we begin the Q&A in about 30 minutes. And we will do our best to answer all of your questions in the order in which they're received and also to answer all of them. If we miss any, we'll definitely follow up. Now to get us started, I am pleased to welcome David Soul, the Industrial Decarbonization Manager for the Industrial Innovation Initiative. David, over to you.
Great. Thanks, Ben. I'm really excited to be here today and join all of you. The Industrial Innovation Initiative, better known as I3, is a coalition of industry, labor, and nonprofit groups that are united by the conviction that those constituencies need to work together to achieve mid-century climate goals. And we were founded back in 2020. Next slide, please. With the World Resources Institute. And we've been working since then on a variety of fronts. Next slide, please. This gives you a sense of our membership. So the convening partners, World Resources Institute in Great Plains, have been working with our members to advance electrification, to advance low carbon fuels and carbon capture. And one of the things we need to do this is to have additional policies. And that's why back in January of 2024, next slide, please, we released our federal policy blueprint, and you can go on our website to get more information about some of those policies. And I think one of the things that is important to emphasize about industry is that there's different solutions in different industries, but we recognize that carbon capture is going to be required for a lot of applications in heavy industries. And we're going to hear today from Leilac to get a sense of where carbon capture fits into the cement and lime industries, and has been mentioned from United to hear about a challenging sector, aviation, and the role that carbon capture plays in aviation. But in addition to those technologies, it's important to underscore that we need the workforce that is going to be ready and able to deploy those technologies. And Kevin Pranis from LiUNA, who's another I3 member, will discuss those technologies. And just one final point I think it's worth raising just to open the discussion today is that we're at a really interesting juncture when it comes to industrial decarbonization. So on the one hand, there's an emerging recognition that making progress both in the short term and in developing the technologies required for long-term emissions reductions is going to be quite challenging. But on the other hand, we're starting to see the fruits of some of the federal investments that have been made over the last few years. So this is a really great time to have this hearing and to take stock of things. And with that, I'm happy to turn it over to my colleague, Jesse Stolark, to introduce the coalition. Thanks.
David, thanks so much. Over to you, Jesse.
Thanks, Ben. As Ben mentioned, I'm Jesse Stolark. I'm the Executive Director of the Carbon Capture Coalition, and you can go to the next slide. We are a nonpartisan collaboration of more than 100 companies, unions, and environmental nonprofits working in common cause to enact and implement the necessary portfolio of federal policies to deploy the full suite of carbon management technologies. And if you're not familiar with all of that, it spans carbon capture at industrial and power facilities, direct air capture, CO2 transport, reuse, and storage. And we're going to touch on a lot of that today. And these technologies are necessary to abate emissions across emitting sectors, foster domestic energy and industrial production, and support high wage family sustaining jobs across the country. And like David said, we're just very pleased to be co-hosting today's briefing with i3 and just really trying to shine a light, especially ahead of Climate Week, on the crucial role that carbon management will play in the industrial sector. And we'll learn more about it today from our speakers, but carbon capture in particular is absolutely non-negotiable for addressing the direct emissions that occur in certain industrial processes, from the physical or chemical conversion of materials to finished goods. And additionally, direct air capture is also crucial to offsetting emissions as we continue to decarbonize industry, as well as removing legacy emissions from the atmosphere. So you can go to the next slide. So we're a big fan of blueprints. So I just wanted to mention, if you're not familiar with it, the coalition also has a federal policy blueprint, which puts forward an ambitious but necessary suite of federal policies that are necessary to deploy carbon management technologies economy-wide. And so for the coalition, we really view the passage of the landmark climate legislation in the prior Congress as the beginning, not the end, of the necessary efforts to build the portfolio of policies that are necessary. And so to that end, I'll just mention we are currently undergoing the process to reimagine our blueprint, and we will re-release that at the start of the next Congress so that we can continue making progress on the demonstration and deployment of these technologies during this critical deployment decade. And so, as David said, it's a really great time to talk more about these different technologies and how they're being applied in the industrial sector. So with that brief introduction, I'm going to hand it back over to Ben to introduce our speakers for today.
Jesse, thanks so much. And thanks to you and David for your co-sponsorship of today's briefing. Now we're ready to hear from our special guests, 4 experts representing different sectors of the economy. As I mentioned before, we're going to hear from Ben King, Daniel Rennie, Rohini Sengupta, and Kevin Pranis. They're going to speak in that order, and I'm going to let them introduce themselves so that I'm not coming back in between and breaking up the flow of the conversation. So they'll be taking it from here. As a reminder, you're welcome to put your questions in the chat if you'd like during the presentations, if that's when they come to you. If not, we'll get to your questions after our special guests have spoken. So Ben, always nice to have another Ben. Ben, over to you to get us started.
Thanks very much, Ben, and thanks both to David and Jesse for the opportunity to talk today. Briefly, my remit today, if you can go to the next slide, is just to talk about the need that exists to tackle industrial emissions and the scale of the challenge that we're facing right now. Next slide, please. So Rhodium Group puts out an annual current policy baseline that takes a look at where we see U.S. emissions headed under the policy that's on the book right now. So that includes, as Jesse mentioned, the Inflation Reduction Act, the bipartisan infrastructure law, and a host of other policies that have begun to start to tackle some questions around decarbonization. In this year's Taking Stock, which came out a couple of months ago, we found that the U.S. was on track to make meaningful cuts to economy-wide emissions, achieving as much as a 38 to 56% reduction in greenhouse gas emissions levels by 2035. But notably, while that does represent between a 2 to a little over 4 times increase in the rate of decarbonization from now until 2035, as we've had since 2005, that rate of decarbonization isn't enough to help the U.S. meet its 2030 climate target under a 50 to 52% target, nor is it enough to put the U.S. on track for deep decarbonization by mid-century. Next slide, please. And what's underpinning that top line number is actually an interesting sectoral story. We find that the power sector is on track for meaningful declines between now and 2035, reducing by as much as more than 80% by 2035 in the best case scenario. And likewise, the transport sector starts to see meaningful uptake of zero emitting vehicles, particularly in the light duty fleet, but also the beginning of a transition in the heavy duty fleet. That in the end leaves industry, as Ben mentioned at the outset, as the single largest emitting sector in the US economy by 2035. Whereas other major emitting sectors do see meaningful declines, the industrial sector remains largely flat in terms of its emissions profile between now and mid next decade. To the extent that declines do happen, they're mostly driven by improvements to oil and gas production, so reductions in methane emissions from oil and gas production. If you go to the next slide, uh, um, apart from oil and gas industrial reductions, what we classically think of as industry, so manufacturing and other non-oil and gas industrial emissions change little between now and 2035 in terms of their emissions profile, which is why we see, from somewhere from a modest decline in sort of our best case low emission scenario, all the way up to increases in emissions by 2035, which obviously is moving in the wrong direction in terms of the U.S. trying to achieve deep decarbonization. These increases are driven in places in the economy that you think of when you think about manufacturing. So increases in emissions from chemical production, increases in iron and steel emissions, cement seeing slight decreases, but still playing a meaningful role. The industrial sector, obviously a heterogeneous assemblage of different industries, each with their own decarbonization challenges, but some of the major movers that we see on this slide are certainly not moving fast enough to decarbonize. Onto the next slide. We find those results in spite of the beginnings of some promising growth for decarbonization technology. So in the modeling that I just presented on, we do see uptake of both carbon capture and installations of electrolyzers that help reduce industrial emissions relative to what they would have been apart from these. I'll focus today specifically on carbon capture because that's the focus of our presentation. Just to say, depending on your assumptions around how relatively inexpensive or relatively more expensive the actual carbon capture technology itself is, we do see the promising start of somewhere between 79 to a little over 130 million metric tons of captured carbon from in the industrial sector by the mid 2030s. A lot of that coming from places that have relatively high purity CO2 streams that are pretty straightforward to grab off the industrial process and put into a pipeline. So that includes ethanol and ammonia and natural gas processing. And then under the most optimistic scenarios for cost and performance, we do see some other opportunities for carbon capture coming in under current policy. But the key takeaway from this, and I think one of the key takeaways hopefully from this entire presentation today, is just current policy is good and a very important start, and we need a lot more, which is why there's blueprints out there that point us in the direction of where we need to be headed. We won't get to deep decarbonization economy-wide, nor in the industrial sector, without substantially more ambitious climate policy action in the industrial sector, and commensurate investments to see deployment of these technologies that can really help decarbonize industry. So with that, I'll stop and turn to Daniel, who will tell us about one of those exact technologies.
Thank you very much, Ben, and a wonderful introduction, which is going to be difficult to follow, but I'll give a bit of a focus on cement, if that's all right. If we can get on to the next slide, if please, Ben. And we'll skip over this one. So cement is a really important substance for our global society. In fact, it's the most cement is the most globally consumed substance after water, and it plays a fundamental role, and all of our infrastructure is dependent on it. Lime has got a very similar process, and again, it's used in everything from paper to glass making. But collectively and globally, this represents 9% of global CO2 emissions, and I think Rhodium Group was indicating this is on track to be one of the largest emitters for the US in the coming decade. There are some really core and important market drivers to addressing this and giving very clear signals about where society is expecting industry to move. And industry's drafted a roadmap for this. Most cement companies have committed to net zero 2050 targets. And certainly Global Cement and Concrete Association has published a roadmap, which I'll talk about in a second, showing how they're anticipating to get to net zero. But as the IPCC summarizes it, it really does rely on carbon capture and storage. Just to give you an idea of how big the cement sector is, 9% of emissions. Our society is growing globally, and 3/4 of the built environment that we need by 2050 hasn't been built yet. And that's from the WRI. And to give some, again, quoting Rhodium, to give some idea of how much that is, that means the equivalent of New York City, all of its infrastructure being built every month now for the next 40 years. So it's an awful lot of infrastructure that's required, and that really does rely on cement. But if we can move to the next slide, please. Again, apologies for all of these graphs and signs, but to get to net zero by 2050, the cement industry has given this detailed analysis, and there are an awful lot of things that can be done. Reduced cement use, efficiencies in design, and pulling all of those levers. There is just still this huge need for carbon capture and storage. And they're anticipating the need to capture 1.4 billion tons of CO2 per year by 2050. And electrification, all of these other things are on in addition to that. So if you could go to the next slide, please. And it's not through lack of trying. So we said this is a hard to abate sector, but the reason why it is all due to this stuff called limestone. This is the primary ingredient that's needed to make cement. And when it's processed, when it's heated up, it releases almost half of its weight as CO2. So that's why we call these process emissions, and that's really why this is a hard to abate sector. It's not like the power sector where we can just stop using fossil fuels and move to renewables. These really are core to making ordinary cement. Can move to the next slide, please. And so LILUNA, which stands for low emissions intensity lime and cement, is really focused on these unavoidable process emissions from the cement and lime sector. As we noted, when you heat this material up, it releases CO2, and in fact, it releases pure CO2. And so the LILUNA technology basically is focused on keeping that CO2 pure as it's released from the limestone. So rather than a conventional plant which mixes the heating sources up with the CO2, we've just got these huge metal tubes, and we have only the limestone in the middle. It's very much like flour, just gets dropped down at the top, falls down. Got a heating source on the outside, making the walls glow red hot, about almost white hot. It's over 1,000 degrees Celsius. And that gives the energy to release the CO2 from the limestone, and it rises to the top. So this is part of the cement making process. It's not, and this can be retrofitted to existing plants. And the nice thing is that because it's just a steel tube, it's optional what type of heating sources we use to create that energy. We can use traditional fuels, low carbon fuels, particularly hydrogen and electricity. In fact, we've built a number of electric units. So that's going to be a really important way of decarbonizing that point too. If you could move to the next slide, please. And with that, we're not working alone. We're working with many of the major cement players in this sector, and we built the rather imaginatively titled LiLUNA pilot plant in Belgium. This has got the capacity to capture 25,000 tons of CO2 per year, and as far as I'm aware, that makes it one of the largest, if not the largest, carbon capture pilot on a cement plant operating today. And that's been running since 2019. That's got one of these tubes in it. That's currently using natural gas, but we're planning to electrify that next year fully. And then this in the center, we've got a picture of the LiLUNA 2 plant, and this is going to be built next year in Germany, and we just use 4 tubes. So that gets us up to 100,000 tons. Strange things happen when you, with engineering, when you make it bigger. That's why we just duplicate it. And that becomes a module that we can then scale to get to any size. And we're in engineering studies with a number of companies to enable deployment at full to capture all of the process emissions as quickly as possible. As has been noted by the speakers, it's really important that this is low cost. It's a low margin material. Everybody in the world needs to have access to cement at low cost, but it's also a local industry. With this unit on the left that we built, we only had 3 of our staff on site. This was built using local labor from across the region. Most of the materials just structural steel in the furnace. We're really designing this to be a modular, simple design that can be rolled out efficiently globally. And I'll look forward to some of the later discussions on that and the importance for this. I'm running out of time. So if we could move to the next slide, please. But it's not just lime and cement. Exactly the same technology can be used for direct air capture. We're in a partnership with the direct air capture company Heirloom, which is seeking to address both legacy and other hard-to-abate atmospheric emissions. We mentioned that the cement industry needs to capture about 1.5 billion tons of CO2. Direct air capture to get to net zero is anticipated to need to capture between 1 and 10 billion tons of CO2. So again, we're working in close partnership. All of the learning, the technology that's been developed both with and for the cement and lime industry is being applied to these electric, fully electric Heirloom units that are being deployed and aimed to be as quickly as possible across the states. But thank you very much for your time. I'm keen for questions later. But if I can pass the over to Rohini now.
Thank you, Daniel. Thank you, everyone. My name is Rohini Sengupta. I lead our decarbonization team here at United Airlines, and that's really the strategy that we are employing for our transition to net zero from our current operations. Today, I really want to talk through our decarbonization roadmap and inherently where we're looking for opportunities to draw down our emissions as we forecast them out to 2050. The opportunities really for carbon capture, carbon removals inherent in those pathways. Next slide, please. So to set the scene a little bit, I just wanted to kind of highlight a few major figures that we have principally guiding us. First and foremost, global aviation is roughly around 3% of the world's global greenhouse gas emissions. However, we recognize that as other industries that may be easier to abate, easy, of course, being a relative term, as those industries decarbonize, and as more of the public flies and there's more aviation or air travel access around the globe, that 3% could and is projected to increase in the coming years. Another kind of key percentage that I think is really important to keep in mind is that our footprint, we don't have a very complicated where does it come from question to answer at United. We know and across the industry recognize that the substantive majority of our greenhouse gas emissions comes from the combustion of jet fuel in our aircraft engine. And so it is really a matter of fuel usage reduction and then replacement so that the carbon that we have to use in this liquid fuel is coming from renewable sources, is not fossil derived, and we are addressing life cycle emissions of our fuel, which we'll get to in a second. Just to level set, especially as you're about to see our roadmap, today's full greenhouse gas footprint, that is on a well to wheels basis, as we like to talk. And so essentially what that means is it's inclusive of production emissions. We have two key climate targets, the first being in 2035, our midterm target. That is an intensity reduction target of 50% reduction from a 2019 baseline level. The second target, of course, is our net zero greenhouse gas emissions target by 2050. And we stated back in 2020 when we initially announced this target, and we're the first to do so, we announced that we would be doing so without voluntary out-of-sector carbon offsets. And so really looking at going back to this 98%, how do we reduce our emissions essentially from the life cycle for, where they're generated? Next slide, please. So this is a pretty exhaustive roadmap, and I recognize there's quite a few layers. We set out to really look at what the different technology needs would be, but also transitions that we could anticipate happening and being available to us by 2050, as we forecasted the emissions reductions that at that year will need to be 100% reduced in total. So I kind of always look at this roadmap as two halves. The four top levers, essentially every lever you see that is not green, these are I refer to as our fuel reduction levers. We should first and foremost try to reduce the amount of jet fuel we're using. Remember, 98% of our emissions is associated with that combustion. And so that will come from a variety of technologies and possibilities, not least of which just ensuring we have the newest, most fuel-efficient fleet in possible in operation and in flight. And so, of course, our bold aircraft orders for the most recent models certainly indicate that especially between now and 2035, a great deal of our forecasted emissions reductions will come from that rapidly modernized fleet. The second sort of large piece, of course, is the advances in aircraft technology, both traditional fuel burning technology, but also, of course, alternative propulsion, which is really exciting, a zero carbon energy source in the future. But as you can see, that's really quite a ways off, and it's limited in its impact just because of the energy density needs and the lightweight needs for flight. And so it would be really kind of very short range, short haul flight that would address. So after you reduce as much of the fuel that you need to burn, what is left over? Of course, a replacement with sustainable alternatives. And so we refer to this as sustainable aviation fuel, or SAF. What you might find unique relative to potentially other roadmaps is that we've broken out our forecasted SAF levers to different, effectively, evolutions or generations of SAF. And I think that for this conversation, that's particularly interesting. And so, of course, we have the SAF that is methods that are commercially deployed today. These are typically taking fats, oils, and greases and converting them through technology that's referred to as HEFA technology, but you can think of it as hydroprocessing, basically hydrogen plus catalyst, to create SAF. But there is the upward limit, both in terms of feedstock availability for that pathway, but also in terms of carbon reductions on a life cycle basis that we would be able to potentially realize. And so as we look at the further generations of SAF, these darker green levers that you see here, or wedges in the roadmap, these are really looking at what are opportunities, not only to have more sustainable feedstock as the source of carbon and the source of energy for our SAF, but moreover, how do we incorporate technology, particularly carbon capture, utilization, and sequestration technologies, to bring down the life cycle emissions of that sustainable aviation fuel? As we look at reducing our footprint, we look at the life cycle emissions of the SAF that we would use relative to the baseline life cycle emissions of fossil conventional jet fuel, were we to otherwise use that alternative. And that's where those reductions inherently come. If A second generation SAF, for example, one really promising pathway that we often see referred to, and we've heard quite a bit about, is referred to as alcohol to jet. And something that can be really promising there is feedstock like ethanol. However, in order to make sure that on a life cycle basis, SAF that is produced out of ethanol has low enough carbon intensity and sufficient enough emissions reductions, technologies like carbon capture can be really, really effectively deployed in that SAF production, particularly in that ethanol production. Ethanol produces a really pure stream CO2 byproduct. Capturing that and sequestering it is not only great for the environment, of course, but really draws down the life cycle emissions of anything produced out of that ethanol. And then chiefly, I would say our third generation of SAF lever, this is looking at carbon capture and utilization in many ways. It's how do we take captured carbon and use that as a feedstock for a synthetic fuel. And I think that is one of the most promising future technologies that we're seeing in the market, that we're seeing emerge in the market. At United, we have a LP-enabled CVC, a venture fund that is aimed at SAF and SAF facilitating technologies that we call the Sustainable Flight Fund. And a great deal of our portfolio investments are either carbon capture technologies or carbon capture utilization technologies, so conversion technologies to take carbon and hydrogen and make a synthetic SAF molecule, which can be a very closed loop story from an emission standpoint, but also really meaningful life cycle emission drawdown when you're looking at a SAF that is synthetically made through that process. So as you can see here, in the near term, these solutions are really in early technology readiness level stages. They're really in sort of pilot and demonstration deployment, which we're eager to support our portfolio companies in demonstrating. But the vision we see for the long term is that these are really essential technologies and pathways, and carbon capture as a facilitating technology for these SAF levers and pathways are critical for us as an airline and others across the industry to achieve our decarbonization goals. And with that, I know we'll have questions perhaps at the end, but appreciate everyone's time, and I'm happy to hand it over to Kevin. Thank you.
Thanks. Kevin Pranis, representing LiUNA, Minnesota, North Dakota. We're the Laborers International Union of North America, representing 500,000 primarily construction laborers and some public employees across the US and Canada. Really appreciate the previous presentations, which I think highlight the tremendous opportunity we have to both create and preserve high quality job opportunities, putting skills to work on climate solutions. So just a quick overview of who we are in Minnesota, North Dakota, represent 14,000 members working on a range of building, civil infrastructure, and energy and industrial type projects. Our union in Minnesota has been a leader on climate. We were the first to get behind 100% carbon-free energy mandate in the electric sector, which now exists in law in Minnesota by 2040. We've been part of transformational work in the electric sector and now working on buildings, transportation, industrial, and agricultural decarbonization initiatives. I serve on the Governor's Climate Advisory Council, and I chaired the state's Clean Transportation Working Group, which was very focused on SAF, among other opportunities. So the industrial sector is really important to our members and to all the other building trades members that work alongside us. Just for context, our largest single source of hours in the metro area historically was coal and nuclear powered plants operated by our largest electric utility. Those coal plants obviously are getting retired at a fairly accelerated pace, which has a significant impact. The largest source of hours for members in northern Minnesota is iron mining, that provides feedstock to the nation's largest steel producers, U.S. Steel and Cliffs. And so that's a critically important sector in terms of preserving the United States participation in that. The largest building trades work site that for all trades would be the refinery that serves Minnesota in the upper Midwest, including jet fuel as well as gasoline and diesel. And so again, that's an example of a challenge we face with decarbonization. And then Sorry for a little background noise here. Then the second largest building trades worksite would be MSB Airport. To Sengupta's comments, like aviation, critically important for us. So we're affected in lots of ways. And finally, industrial facilities make products that are absolutely essential to our work, right? Everything our members do, or most of what we do, involves steel and cement, asphalt and fuel. And so, for our construction industry to succeed, we need to figure out ways to decarbonize, those materials, whether our work in those facilities or we're talking about the components to our work. The other thing for us is that the industrial sector is critical to local communities and economies. It's not just about the number of steelworker jobs directly employed in a mine or a refinery in Minnesota. And it's not even just about all of the very significant ancillary services and investments, all of the construction contractors that we work with, all of the other investments that these facilities make in order and services that they require to operate, which create a huge economic impact, much larger than the number of employees of the facility itself. It's really about the quality of the jobs, because economies and communities run on money rather than the number of jobs. And so if we look at the kind of high quality jobs that our contractors offer, that many of these industrial facilities offer to their employees, you're talking about fully employer paid family health coverage. You're talking about pension and retirement programs that actually allow for people to have a decent income in retirement, support their families, build wealth. And you're talking about middle class wages. And so as we look at industrial facilities that might be threatened with closure because of economics, because of the energy transition, typically a quarter or maybe a tenth in terms of the total economic contributions of these high quality jobs. And so I think that's what's critically important, is these are anchor jobs that support communities and support a whole bunch of other businesses that wouldn't survive, the hospital, the restaurant, whatever you're imagining. All of those things require these jobs. So retaining them is critically important. We're excited about all the jobs building these climate solutions and our members putting their skills to work, but it is probably even more important to simply preserve these facilities, because they provide work year in and year out for us on maintenance, for the operational employees on operations, and for the communities and all of the ancillary services. And so protecting these, making sure that that work is not offshored, but we're instead doing more onshoring. And so what does that mean in terms of workforce? Well, we hear a lot in climate conversations about electricity-based solutions, and we're very bullish on that. We're doing wind and solar, right? We're looking at EV charging. There's all kinds of electricity-based solutions, but there are limits to the application of electricity. And as we've seen, there are also significant and growing bottlenecks on supply chains and even availability of labor. We need lots of more electricians, and the electricians, the IBW is training folks, right? But the electrical is not the only way to solve problems. And so we're equally excited about chemistry-based solutions, right? And mechanical-based solutions, because it involves a different skill set. It solves different problems. It also means that you're bringing plumbers and pipe fitters, insulators and boiler makers with all kinds of experience working in power plants and refineries into the solutions here. And that means you're putting those skills to work, instead of telling those individuals and our members who work in industrial settings, we don't need you anymore because we figured out how to solve all our problems with electricity. And we just don't think that's the case. And you heard compelling examples here of chemical processes that we can't replace with electricity, right? Or energy density of fuel that simply cannot be replaced with an incredibly heavy battery that you'd put on a plane. And so we see this as a chance to redeploy our members and put those skills to work, preserving these really important institutions that keep economies going. And so that's sort of the summary. We're working carbon capture and hydrogen, incredibly excited about the technologies everyone's talking about here today, and look forward to working on the solutions.
Wow, what a shame we don't have experts to talk to us today. My goodness. That was a terrific overview of the market from all four of you. Really appreciate your willingness to share your insight and expertise with us. So thank you, Kevin and Rohini and Ben and Daniel. I'll invite all of our speakers to turn your cameras back on now for our live Q&A. We're starting to get some questions. We have one in the chat and one in the Q&A box. So I'm going to start there. As a reminder, if you do have questions, reporters who are joining us on the line today, please put them in the Q&A or the chat box, and I'll get to them as we go. You can also use the raise hand feature, and I'll call on you as well. So first one is from Craig Bettenhausen at Chemical and Engineering News. Hi, Craig. Specifically for Rohini, SAF, even with subsidies, is more expensive than Petrojet. How much of that gap needs to close before United will be able to buy large volumes?
Yeah, thank you for that question. Definitely the elephant in the room with SAF is the green premium, and I think that's likely the case with many of these low carbon products that have such premiums. I will say for large volumes, I think significantly prices need to come down, but also just the cost to produce needs to come down. Right now, SAF that is being produced is conversions from renewable diesel or from traditional refining. And so there really needs to be kind of a willingness from the financial sector on how we can properly invest from an infrastructure level in sort of these new production facilities. That's sort of what we need to get the economies of scale required to really start seeing meaningful reductions in the green premium. However, in the near term, I think two things are really key. One is we have a program called the Eco Skies Alliance program, where our top corporate customers, cargo customers, this week rather, we just announced the introduction of our first sports team, the San Francisco 49ers, all paying the green premium, working with us. And essentially, because they have their own climate targets, their own net zero ambitions, helping to essentially, they buy SAF certificates. We are able to adopt more SAF into our operations and effectively allocate the reductions for those who know the greenhouse gas accounting parlance, the scope 3 or travel emissions reductions to those customers. And they're able to then see reductions in their greenhouse gas inventory just as we are. And so I think collaboration is really key here, finding those like-minded other corporates where there's complementary interests. They want to reduce their travel emissions. We can allocate travel emission reductions if they help us buy the SAF. And collectively, we can sort of have a willingness to pay that maybe just on our own is not as tenable. The last thing I'll offer, and I think we would all maybe agree, is that policy can really change the way in which these products are cost effective. And that's not least of which with SAF. The IRA, of course, passed the first federal tax SAF incentive with the tax credit, but more in terms of investment, more dollars toward investment in production can certainly bring down the green premium as we have more supply online. And so really looking for policy avenues to drive down that premium as we're seeing come up in various states around the country in the US.
Thank you so much, Rohini.
Could I actually follow up? I just wanted to follow up on this one.
I
think those absolutely. So we're working, I think you'll see hopefully some leadership from the public sector in some areas where the public sector is a main purchaser, right? I mean, you see, or a limited number of institutions, universities, right, that are willing to spend more or can, there's sort of a mandate to spend a little more. And I think having those products available that are clearly understood is important and that are considered to be reliable. So people know what they're actually getting, what they're paying for, and that it's making an impact. I think we're working on a Buy Clean program in Minnesota. I know there's Buy Clean programs elsewhere that's starting to look at structural steel, rebar, asphalt, concrete, right? Like what are those attributes, and do we start setting some targets and incentivizing, leaning the market in a little more? And I think as those products become better developed, there will be some more pressure on buyers. I agree that it's a big problem, and also agree that there's policy options, both including more kind of funding and policy supports that could nudge industry in the right direction, but that agree that it is our big problem right now is the lack of a clear market for those products that we need to better define, and that government really needs to take some role in helping define and drive that demand, because if the public sector is not willing, then it's a little unclear why private actors are really going to follow through.
Thanks, Kevin. Anyone else want to chime in? I don't want to cut off the conversation if anyone else wants to say anything.
Well, if I may, certainly some of those products, for at least for cement, are being developed by various parties, at least in Europe. And just to give a context of what this might actually cost, is either a green premium or or frankly, everything else might just be a liability, is that it's for a house, decarbonizing the cement required would only increase its overall cost by about 1%. So again, all of these policy levers do need to be pulled, and I fully agree. I think public procurement can play a really important leading role as long as that current premium is acknowledged and taken into account.
Thanks, Daniel. We have two more questions, it looks like. As a reminder, for the reporters on the line, if you have questions, you can put them in the Q&A or in the chat, whichever is easier for you, or you can use the raise hand feature and I'll call on you to say your question out loud yourself. But first, one from the chat from Amina Saeed from Cypher Media. Hi, Amina, nice to see that you're here. Technology, labor, incentives are all pieces of the industrial decarbonization puzzle. What is missing is lack of off-takers. What strategies do you all have for shoring up demand? How do you persuade your clients to pay a green premium for your decarbonized products? Touched on this a little bit, but let's get more into it. Who wants to go first?
Well, I touched on it a little, so maybe I'll pull the thread even further. So I think that a part of it is for us. I mean, we are an off-taker and have obviously customers that drive demand for us. So in some ways, we're a demand aggregator, depending on how you look at it. And one thing I will say is that there are, especially in the corporate space, especially as there is more rigor and attention and even regulation around the reporting and commitment to climate targets, not just for a corporation's direct emissions, but for its indirect emissions, which for many corporations, but particularly those with a large travel footprint, is inclusive of its travel emissions. In those scenarios, we do find a lot of alignment with these companies. And so we launched our EcoSkies Alliance program in 2021. We've had effectively 4 rounds of it. Every year we have procured more SAF than the year before. We've had a greater number of individual members of the Alliance, but also we've seen larger purchases of SAF per individual member in cases. So I think that there is just a lot of demystifying what is very complicated technology in some cases, with your sort of demand set and your demand indicators and your customers in our case. But then largely, it's also, we have taken on the function of essentially aggregating where there is interest, willingness to demonstrate real emissions reductions in travel emissions and in business travel emissions. Also in shipping, right? Because we also work with our cargo customers and our freight forwarders. We're seeing a lot of traction, a lot of interest, and a lot of excitement. And it's really just how do we continue to aggregate that, to grow that, and how do we ensure that we are working with our customers in the most efficient and effective way possible, right? Meeting them where they are. But it's been really, really encouraging. And the nice thing is actually many of those EcoSkies Alliance customers, a few of those are actually limited partners or LPs in our forward-facing investment fund for SAF. And so you see that there is this familiarity and desire to grow the scale and supply of solutions, not just within the industry, but those customers that really rely on the industry most often. So I think that for us, it's really focusing on corporates because they have committed public targets. There's an accounting principle, and those with targets that are inclusive of their indirect emissions or their Scope 3 emissions. I mean, they've been really, really active participants in our program and in dialogue across the world, really, on SAF.
Thanks, Rohini. Anyone else want to tackle that?
I think, thanks, Ben. Maybe one other thing that I'd point to here is maybe an overlooked portion of government investment, which is, you've got a technology in many of these cases that is off the lab bench. It's off the sort of like small scale demonstration and is really trying to do sort of first of a kind commercial scale deployment. Federal support for those types of facilities. We've seen this from the U.S. Department of Energy and their industrial decarbonization investment program, and elsewhere. There's hydrogen hubs. There's carbon capture demonstration projects. There's all these places to sort of like prove out the technology at scale, and to get folks where appropriate, to get off takers of whatever the end product is, used to interacting with some of these new technological approaches. So it has the benefit of familiarizing more folks with the technologies, and also hopefully improving technological learning. So you're doing it at scale, so you're like seeing how this stuff is actually working, improving investor confidence so that you're not facing a relatively high cost of capital, but you're actually saying, no, we've got a Planet 2 that's running, and so help us bring down the screen premium by giving us more favorable rates on what we're trying to finance. That's an important piece of the puzzle that maybe gets overlooked from time to time, but is another place where the federal government can step in addition to some of these direct offtake agreements that have been talked about in the past.
Thank you, Ben. Daniel.
Can I just follow up on that? I couldn't have said that better, Ben. And again, for these plants, these are low margin industries that have got the infrastructure around a cement plant is enormous, and it's really old too. Most of these were built in the 70s, and they will keep going for as long as they possibly can. So it's a huge risk for these companies doing large investments. And again, it's not just that risk sharing that really does help with some of these federal and state benefits, but it's a little bit of continued, at least for the first few generations, because it will be the big boys with the established but quite inefficient technologies that grab all of those incentives first because they're bigger. But it really will be the more innovative ones that do just need that continued support. So at least for a generation or two, there will be subsidy until, frankly, it's proven, and then that shouldn't be required at all. Then it's not a green premium. It's just all of the inefficient plants will not survive when there are decarbonized, more efficient, and better solutions out there. So it's that this initial period is really difficult. And again, it's not just industry, it is investors, and these are very big sums of money, and it's very high risk. So yes, sharing that really does help, because it's not really at the moment.
I mean, and to pick up on that, I mean, what is becoming increasingly clear as we're making historic investments, both energy, other climate infrastructure, and then just overhauling aging infrastructure unrelated, is we're having bottlenecks, and we need all this stuff, and we don't have lots of surplus cement, and we don't have surplus steel, and we don't have, usually, right? Not anymore. We don't have surplus transformers, and so all of that manufacturing capacity is needed, and any path that basically sort of like puts them out of business is one that potentially just makes the investments harder to do. So there really isn't a solution other than spending some more money, in as strategic a way as possible to try to facilitate that and unlock that, and then get to the place where, okay, now we're back to business as usual, and those costs come down a little bit.
Thank you all. That was really helpful. We do have another SAF question, but I don't know who it's from, so I'm going to skip over it now. If you could just go into the Q&A and identify yourself, that'd be great. In the meantime, Craig Bettenhausen from Chemical and Engineering News has a question for Kevin. Kevin, can you speak to the retraining needed to put the existing oil and gas technical workforce onto CCUS facilities?
So I don't have the full expertise here. I mean, I can start. I think it just depends on the application. And so I think let's just start with pipelines, which our members do a lot of. And there we're pretty much at zero. In other words, all of the changes from a CO2 pipeline versus an oil pipeline are basically consistent, but also the changes will be in material, sort of like tweaks to materials around pipe. If it turns out that those are needed, that probably won't affect the skill sets involved in construction at all. So just like a gas or oil pipeline, it's kind of important to build it right, and to make sure that the trench is laid right and that you're not creating corrosion and you're not creating undue stresses, right, because of construction. And that's true for any high pressure piping, and that can all have consequences. So that's one where the skills are there and those exact same people are ready to go to work, and hopefully soon implementing those solutions. I am not the expert on sort of like refineries. What I do understand suggests that a lot of the new technologies are actually simpler, right? Again, we're moving toward less manual technologies, right? Less manual technologies, more plug and play. And we're seeing that in a lot of sectors. And so it will be my guess that actually slightly fewer skills will be required, right? Similar or slightly lower skill levels, especially to operate a newer facility, because the equipment is coming in better shape to begin with that can handle more of the things that used to be handled sort of mechanically, by people in a facility, an aging chemical, sort of plant or refinery. So that's the general take on it. We're certainly looking at, hydrogen has some special characteristics, right, that are a little different. So if you're maintaining a hydrogen facility, there will be some update on that, but it's not, I would say it's not of a different kind. At least none of what we've looked at so far is of a fundamentally different kind than the sort of work that we already do. And I will say that every apprenticeship and training program is actively pursuing all the information available on the new technologies and bring that in for the new apprentices. So the new apprentices coming out will actually have the most up-to-date information of anybody in the workforce, because, obviously the training centers want to get ahead of the curve. And so if that's a geothermal or other application, they're already training it.
Great. Thank you, Kevin. And Craig, if we didn't fully answer the question, although I feel like Kevin did, send me a note and I will definitely follow up with you. We have time for one more question from Allison Prang, freelance climate journalist. Hi, Allison. Question on carbon capture generally. What's the range of success rates for various carbon capture methods? Does some CO2 still escape at points, or is the rate often lower than 100%? And Jesse went into the chat and said, can you clarify if you mean percentage capture or percentage leakage? And Allison, you said the first one primarily, but if you want to speak to the second one, go for it. So Jesse, we'll start with you. And I think this is our last question.
Sure. Thanks, Ben. Thanks, Allison. So when we look at industrial facilities, carbon capture technologies, all of the speakers today have alluded to this, but I think it's worth underscoring. Carbon capture technologies is a crucial technology, but it's one of many that needs to be deployed at an industrial facility. So if we take a cement facility as one example, they're going to have multiple emission streams, and typically you're going to apply the carbon capture technology to the CO2 streams where you have the highest purity, because that's going to have the lowest cost of capture. So you might be going after one or two maybe emission streams at the facility. And then as far as percent capture rates, we can achieve very high capture rates. Technology is able to do that up 90%. When you look past 90%, it's very costly to capture 100% of the CO2 emissions. There's research that's going on actively, from funding from the Department of Energy to reach very high capture rates. But typically, what we're looking at today is capturing those the highest purity streams to the highest percentage that's technologically available and cost effective. And then also you're going to need to look at other strategies to address the other emissions from a particular facility. But I don't know if others want to follow up on that.
Well, if I may, given I should be talking about carbon capture on cement plants, but for direct air capture, actually, it has to be verified net emissions. So that is verifying taking atmospheric CO2 and ensuring that it's permanently and sequestered, and that there is a net reduction. That's the fundamental basis of direct air capture. And certainly within the technology, you're quite right. It's about doing this the most efficient way possible. And so some of these streams, we can get very, very high capture rates. And then we just allow different things like electricity for industry, capture the high process emission and fuel switch. So it's, but actually sequestration by itself is very well known. It's been done for many decades, and all of these, the monitoring and permitting for CO2 storage is extensive to make sure there is no leakage too.
Daniel, you get the last word. Thank you. And for the person who has to follow up on SAF, just send me an email and I'll make sure we get that over to Rohini and others so that we can answer it. I'm going to turn it over to David for a couple quick notes, and then we'll say goodbye. David, if you're speaking, we can't
I
hear
got
you.
it. Got it. Thanks for joining. Just wanted to highlight at the end the industrial demonstration projects that DOE announced in March of 2024. So these are in addition to the carbon capture demonstration projects that Ben mentioned. The demonstration are for 2.5 million. So this $6 billion again gets at the point that Jesse just raised about the multiple paths and multiple sectors and solutions. So some of these are carbon capture, a couple of these are large carbon capture awards, but they're in various industries. And I think what we heard today should give us a lot of cause for optimism, that we're hearing about a lot of innovative solutions. And I know that the coalition, and I can speak for I3, is really excited about working with these partners to advance those solutions. So I really appreciate everyone's time today and look forward to continuing the conversation. Thank you.
That's all the time we have today. Special thanks to Ben, Daniel, Rohini, and Kevin for joining us to share their really fantastic expertise and insight. On behalf of Jesse and David, thanks so much for joining us today. Please get in touch with me if you have questions or want to know more about the topics we addressed today. And we do very much appreciate your interest in spending a little bit part of your day with us. Thanks, take care, and be well.